Hello, my name is David Abecassis, and I work for the Machine Intelligence Research Institute. I'm here today with Scher to talk about some of his recent research. Our work here is to address catastrophic risks from artificial intelligence. And Aaron, welcome.
Thanks. Yeah, we're going to talk about this paper I wrote recently about how to verify restrictions on frontier AI research, which might sound crazy, or we'll get into a bunch of the motivation maybe to start off. But what do you have for us?
Yeah, well, look, give us the context for why is this research important?
Yeah. So a growing number of scientists are becoming worried that developments in artificial intelligence could eventually lead to catastrophe for humanity, including human extinction. Folks at MIRI wrote a book last year called If Anyone Builds It, Everyone Dies, Why Super Intelligent AI Would Kill Us All, maybe Why Superhuman AI Would Kill Us All. That sort of lays out, the core thesis, if you will, that backs up a bunch of what we work on, which is that humanity's not ready for this technology. If we built it, it would go catastrophically wrong, so we need to prevent people from building it.
And how are we going to prevent them?
Yeah, so that's the project that our team focused on last year. We wrote a larger paper that we called an international agreement to prevent the premature development of superhuman AI. And in that paper, we talk about sort of two main mechanisms that are preventing AI capabilities from advancing. So if you look at the AI field, basically we have a field in which AIs are getting smarter and smarter every year, actually every month almost. It's a very, very fast moving field. And there's a question, well, if we need to prevent super intelligent AI from being developed, then we need to slow down that capabilities advancement or bring it to a complete stop, if possible. And so our agreement asked sort of how do we do that? And we identified two main mechanisms. One of those is controls on compute. This is the specialized computer chips that are used to train today's frontier AI. And the other is restrictions on the research that people are doing. So yeah, why do we need both of those? So there's a paper that identifies the AI triad, which is three major inputs to AI development that lead to better AI capabilities. Those are compute, data, and algorithms. So again, compute, that's these advanced computer chips like NVIDIA H100s and B200s, AMD GPUs, Huawei SN GPUs. They're specialized computer chips. They're extremely expensive. They're not what you have in your MacBook at home or anything like that. They're intended to be run in a data center. And a lot of the development that we've seen in AI to date has been from people scaling up the use of those computer chips. That is, buying more of them and using more of them for longer in training, as well as the chips getting better.
How much do these chips cost?
Yeah, so the H100, which is sort of the big popular chip up until maybe this year, was for a couple of years, ran for around $30,000 for one of these chips. And now the number that you actually use in training is sort of minimum 1,000. Some of the Chinese developers are using 1,000. Many of the American companies are using tens of thousands or hundreds of thousands of these chips in their training runs.
That costs $30,000 a piece.
Exactly. So this isn't exactly something that people are doing, at home. The academics, some like a lot of the most well-resourced academic labs often have, a dozen or a couple dozen of these chips.
So bring it back to our agreement. Who is the agreement between?
Yeah, so our agreement focuses primarily on the US and China for a couple of reasons. One, the US and China are leading in AI development, and so they're the ones that you need most to be at the table if you want to have a halt on frontier AI capabilities. And then second, they're global superpowers who, along with their allies, control a large chunk of the AI supply chain. And so if they wanted to, they could actually impose a halt on this technology for many years.
And so they're going to monitor and restrict the use of computer chips.
That's right.
That was one part.
Yep. And then there's this other big part that we talk about, which is research restrictions. And again, the motivation there is that AI capabilities comes from both compute and data and algorithms. And so if you just put controls on the compute, then progress in that data and algorithms is going to still cause AIs to get better. Nobody knows for sure how much better. This is like an unsolved scientific question of if you, cap compute at 10 computer chips running for 10 hours, how intelligent of an AI could you train? Nobody knows for sure. The algorithms are getting better, every year and, on a faster timeline than that. And people are coming up with better ways to generate synthetic data. So that's synthetic data, meaning AI generated data, which, sometimes when the AIs train on that, it gets them to be even smarter than if they just read human text. And so basically we have advancements in data and advancements in algorithms. Those are going to keep going by default, even if you have, compute controls. And so we don't know how fast the movement in that space will go. I think we have some reason to think that it might be very fast because historically it looks like it might be very fast. And we have some other research that I worked on a few months ago, sort of look at that rate.
And it's not constant. Besides, it could be quite sudden. It could take us by surprise.
Yeah, exactly. Some of the innovations in this space come out of kind of nowhere and move very quickly, if you will, or cause AI capabilities to move very quickly. And I think that, one of those examples is the sort of reasoning model paradigm, where we like sort of saw a big jump from, GPT 4.0 was the best AI model for a while, and then we saw O1 preview and the O3 model, and now we have a bunch of reasoning models, and almost all the models being developed these days are these sort of reasoning models that spend a long time thinking through their answer before spitting out a final answer. And I think, some of these developments are slow in their implementation, and like it takes a long time to really scale them up. Some of them might be much faster. And I think, one of the concerns people have is, well, there's a lot of computer chips in the world. So if you come up with a better algorithm that's able to use those computer chips more efficiently, then that might result in much faster AI capabilities on a really, really compressed time scale, because there's a lot of computer chips sort of sitting around. This is the idea of like a compute overhang that sometimes people talk about. But sort of besides that specific precise point, basically, yeah, some of the innovations here cause AI capabilities to jump significantly.
Okay, so we've set up that we need to buy more time by slowing down AI progress. We're going to monitor and restrict the use of compute, and we're also going to restrict certain types of research. The problem that this paper addresses comes in at this point, which is verifying that such restrictions on research are actually being implemented successfully.
That's exactly right. And to motivate that verification point, I think often when we talk about our international agreement with folks, their immediate response is, what about China? And we go, wait, we wrote an international agreement because we know that China's a problem. If just the US slows down, that doesn't do anything about AI development in China. You need an international agreement. It's in the name.
If anyone builds it.
If anyone builds it, indeed. And so I think, one of the objections we get is, what about China? The next objection that we often get is, but China would cheat. China often has these international agreements that they sort of sign onto on paper, but then they kind of go do their own thing and they don't actually follow through on their commitments. And if you talk to people in the international relations space, it's sort of a historical problem. We are not discrediting that problem at all. We accept that is historically a problem. The solution is that you have to do more than just trust them. You have to verify that they're actually following the rules. This isn't new. Ronald Reagan historically said trust but verify. And I think that, in fact, you don't need to trust if you have good verification. And we don't expect necessarily there to be much trust here, because the US and China just don't trust each other on this technology.
And it's also, that's exactly right. It is also both directions. It's just as important, it's just as good statecraft for the United States to ensure that China's needs are also being met with this regard to verification.
That's exactly right. Yeah. So that's sort of the motivate the verification point is, okay, it's good to have rules on paper, but that doesn't get you the whole way. You need to make sure that people are actually following the rules. So the question then is, okay, we're going to have rules restricting the research that people are allowed to do, especially research relevant to frontier AI capabilities. How do we make sure that everyone's following the rules? And the paper that I worked on was trying to answer this question.
So one of the first objections or key considerations will be that people will say, look, this research is like math. How can you possibly hope to track the kinds of research that's happening here?
Yeah. So I think there's a few things here. One is that some of this research is kind of like math, but a lot of it is very experimentation heavy. Why is it experimentation heavy? Well, one reason is that we don't understand the neural networks that we're building today. The field of AI currently is in this paradigm known as deep learning, in which we take large neural networks, that's an amalgamation of hundreds of billions of numbers, and we feed in a lot of data, and the neural networks start doing interesting things. We don't understand them deeply, and so the research progress that's made is often someone comes up with a clever idea, and then they have to go test it. Many of the clever ideas don't work at all. Some of the clever ideas work when you test them on 10 computer chips, but then when you scale up to 100 or 1,000, they don't work anymore. And so one of the sort of big points of optimism here is that a lot of AI algorithms research requires compute to test the ideas, basically, and verify that they're working both at a small scale and then also verify that they continue working as you scale up.
And just to remind, we're talking about at the small scale, this is $300,000 of hardware, right? Which is not all that small. And at the large scale, we're talking of 10 to 100 times that much.
Yeah, I think I don't want to sort of overstate this too much. I think that these are questions that nobody has a super good answer to, but I think the early evidence here points to, for that early stage research, you definitely need a non-trivial amount of hardware for rental costs that are, well into the thousands of dollars. And then buying the GPUs outright would be much higher than that, hundreds of thousands of dollars. And then for the sort of actually scaling up, you're going to need a lot more than that. on the order of thousands of ships for, a couple days at a time.
So one inroad to monitoring, to making the research legible, to understanding when it's happening, is by tracking the compute that it depends on. What else?
Yeah. So I think that you can also focus on the researchers who are actually carrying out this research. Why might we be excited about or, worried about this method? Well, we certainly might be worried for reasons having to do with government overreach and, authoritarianism and sort of government over surveilling of these people. I think that's like definitely a legitimate concern here. Simultaneously, there aren't very many people who this actually pertains to. The vast majority of people can't do frontier AI capabilities relevant research.
I can't do frontier research. How many people are we talking about?
So I think that we're talking on the order of a few thousand or tens of thousands of people, and potentially even smaller depending on like where exactly you want to draw the line, right? I think, with a lot of fields, there's sort of the very best experts, the top 100, but there's also a top 1,000, there's a top 10,000. And I think it depends where you actually want to draw the line. I think a reasonable place to draw the line would be somewhere in the single digit thousands or maybe low tens of thousands of researchers who, those folks are contributing the vast majority of this progress so far. And so if we wanted to have an international agreement that was preventing this research from going on, one way to verify that would be to sort of keep track of what those researchers are doing and making sure that they're not doing the frontier AI research that is now illegal under the agreement.
Great. Before we get into the full list of mechanisms, I also want to ask about a topic right now that's on everybody's mind this year in particular, which is the advancements in the utility of AI agents for things like coding and, for instance, doing AI capabilities research. What are the implications of that?
I think the implications are very large. When I went into this project, I was primarily thinking about that small set of human researchers that are smart enough and have the skills and expertise to contribute to frontier AI development. That's no longer my main focus. I think that basically AIs will soon be doing a large fraction of AI research. And with that, verification needs to focus instead on the AIs rather than on the human researchers.
Wow.
By soon, I think it's really hard to know it for sure. It could be, I think that right now, AIs are doing some amount of coding and AI development projects.
Certainly.
Are they doing something like 10% or 50% or 90%? I don't know. I think that the public information here is somewhat scarce. This is a great example of a place where AI companies could be, telling more to the world about how this situation is going. They have it as one of their goals to automate AI research. Maybe they should let us know how that's going because it's going to have a bunch of important downstream implications. But I think right now, we're early on in that process. One of the classic takes I have is the AIs are never going to get dumber, right? Like from here on out, the AIs will either stay as smart as they are, or they will get smarter. They'll get smarter is the main bet that I think you should be taking. And so if we look and we say, okay, maybe the AIs right now are doing something like 10% of the research. Well, it's going to be at least that high in the future. It's probably going to be much higher. I don't know. If I were to take a guess, I'd be say something like 2027 or 2028, maybe 2029 is when the AIs are doing the entirety of the research process. But I wouldn't be particularly confident in those numbers. I think it's pretty hard to know. That is to say, verification is going to need to, again, really focus on AI agents or AIs themselves that are doing this research.
Okay, well, you've laid out a bunch of mechanisms that are relevant to both monitoring humans, monitoring compute, and monitoring AI inference. So where do you want to begin? Should we talk about, I guess, what are the most important mechanisms? You have a list of 28 here. I don't think we're going to name all of them right now.
Yeah.
What are the key points? And I guess maybe one question I would have is, do you see there being a key stack? Like, is there a minimum viable articulation of what mechanisms would suffice if this was, for instance, implemented today or implemented in some post-AI researcher-dominated future?
Yeah. So this research, I would say, was pretty early as an attempt to solve this problem, and I don't have a confident answer to that question of what is the minimum viable stack. I can walk through what I think the sort of top mechanisms are, where by top, I sort of am combining efficacy and cheapness of implementation, both sort of monetarily and in terms of privacy and security concerns.
Great.
So I think that one really obvious thing is to have better whistleblower protections and really encourage folks to blow the whistle on this. Again, we're imagining a world in which AI development becomes internationally illegal and taboo. That is a development in which it's reasonable to expect that some of the people partaking in those efforts will want to blow the whistle because they think what they're doing is morally wrong. The reasons they might think it's morally wrong, well, a lot of people hate AI today, and a lot of people are going to hate AI a lot more in the future, I think. And under this agreement in which the world has come together to ban this technology, we've said it's sufficiently dangerous that we need to like actually bring the industry to a halt in a major way. That is a world where I think there's going to be major public sentiment against people doing AI development. And so it's not crazy at all to think that some of the researchers who today are very, ideologically driven and want to build this technology will have a change of heart there. For instance, I think that, their family wouldn't want them to be doing this because it's an incredibly dangerous thing that puts everyone at risk.
So what can we do? What can we do to incentivize whistleblowing?
Yeah. So I think that there's a couple maybe streams to go down. Looking at history, the SEC's Dodd-Frank whistleblower program has been in place for a while now, since around 2010, I think. And one of the things that it does is it gives financial rewards to whistleblowers proportionate to the scale of the problems that they whistleblow on. And so it's something like you get 10% to 30% of the sanctions that were collected from your whistleblowing. Now, you couldn't apply literally that same exact financial mechanism here necessarily, but I think you can certainly lean into the fact that, monetary payouts would incentivize people to whistleblow. There's another big important thing here, which is that we're thinking about an international agreement. And so when people are whistleblowing, it might be part of, oh yeah, I was recruited by the CIA to help with this project, and now I'm whistleblowing on the project. The CIA might not be very happy with that. And so I think a useful part of whistleblowing might be asylum, basically, for people and their families to move to other countries that might be, or that are, less likely to sort of retaliate against whistleblowing in effect.
Yeah, it seems like that could maybe cover certain contexts, like if frontier development left, for instance, the United States and went to a third-party country where perhaps there was a less strict enforcement regime, and whistleblowing maybe would affect that domain, and the U.S. would be able to extract them, for instance.
Yeah, and I think it also might be relevant to the U.S. and China. I think it's a lot of, again, when I talk to sort of other folks about this research, often people are like, oh man, you expect someone working on the Chinese secret AI project to whistleblow? And I'm like, well, probably not by default, but maybe if we add some incentives like asylum, that might make it more likely or more feasible. And that's just, given the level of state control going on in China and the level of sort of control of the population.
So we've covered whistleblowing. You've mentioned criminalization. Maybe you want to say more about its impacts.
Yeah. So I think that this is not exactly a verification mechanism, but it is doing a lot of work in my understanding of this topic. I think that people don't like doing illegal things, especially if the consequences are large. And again, we're imagining a world where the AI research has been deemed to be a threat to all mankind and thus illegal. I think you could think about this as maybe doing AI research is seen as similar to committing war crimes. And I'm like, yep, that sure is a disincentive for people to do it. The criminal penalties are also a major disincentive for people to do it. And so I think that, we have the case now where, again, there's many thousands of researchers that are trying to push forward the state of frontier AI. And I think that there's a bunch of reasons for that, but we are imagining a world in which that changes. And part of that change is that a lot fewer people will be trying to do this frontier AI research. If I were to make a guess, my guess is something like 1% to 10% of the effort continues. But again, that would mean something like 90% or more of the researchers stop working on this for, a combination of moral reasons and legal sort of risk reasons.
Intelligence gathering is a broad category.
Sure is.
Let's break that down a little bit.
Yeah. So I think that when we look at historical attempts to detect covert science projects, be that, designing a new stealth fighter or designing missile systems or, designing a new nuclear submarine design, that kind of thing, how do states typically get information about these projects? They use their range of intelligence gathering tools. That includes cyber, it includes human intelligence, it includes, satellite imagery. There's a whole range of things here. They're not all going to be relevant to AI. For example, I think satellite imagery is probably not going to be relevant to finding, covert AI research projects. And the reason for that is that the actual research part, again, might be done by humans that don't necessarily need a lot of GPUs sitting right next to them. They might have a small data center or a big data center that they're using, but it doesn't have to be co-located with them. It could be separate. And also it could be sort of distributed with, small pockets of compute compute of AI computers. So I think satellite imagery probably isn't going to be relevant, but I think human intelligence very well could be. Again, that could include whistleblowers or defectors. It also can include interviews and traditional espionage and spycraft.
Yeah. So to be clear, so we expect that a feature of the verification regime for the U.S. and China might be each side interviewing each other's relevant researchers?
Yeah, that's exactly right. I think that, again, this sounds a little bit sort of crazy, but I think it's just I think there's ways to structure this that make it pretty viable. For example, you have someone from the host country overseeing the interview, and they're allowed to approve questions and whatnot. I think this is just not a crazily surprising idea. And I think I should probably know my paper a bit better. But I think that so under the Chemical Weapons Convention, they have sort of a similar example where, and keep in mind that the Chemical Weapons Convention hasn't actually featured many, if any, inspections. But I think this is, again, it's codified in international law. Countries agreed to do this for chemical weapons. Is that inspectors can come in and they can inspect a facility and they can interview the personnel at the facility. And I think also they have
on demand. There's a challenge inspection.
That's exactly right.
And you're referencing how it hasn't been utilized in practice, but the provision exists.
That's exactly right. Yeah. And again, you can have representatives from the host country overseeing those interviews. For instance, they can object to any questions that they think might be too sensitive. And so I think we have some structure and ideas from previous agreements for doing something like this. So I think it's just not that crazy. I think it's also not really costly at all, basically.
Well, it's super interesting to note the precedent of the Chemical Weapons Convention in that you have this mechanism that has actually not been used, but arguably perhaps does real work to dissuade certain types of research.
Yeah, totally. So I think that was sort of whistleblowers, intelligence gathering, and interviews that we've just talked about.
Mm-hmm.
There's a range of other options. One sort of frame I want to give to folks is that we can split out our verification mechanisms into a couple categories based on what they're trying to find. You can think about this verification problem as having sort of two components. Are there covert projects that you don't know about? And trying to find those projects is sort of one prong. And then for the projects that might be organizations, companies, data centers that you do know about, how do you actually make sure that those are following the rules? And so you could think about this as sort of a detection of covert projects versus monitoring of declared projects is maybe one way to sort of split that up. And the things that we've been talking about, I think, fall into a mix of these, where I think whistleblowers and intelligence gathering, those are going to be focused on covert projects. And then, the interviewing, well, you need to know who to interview, right? And so it might help to have, and that might apply more to sort of declared projects.
What other mechanisms are relevant for monitoring declared known high-risk organizations?
Yeah, so there's a variety here. I think sort of simple stuff is having, auditors that go into the organization and have access to the communication channels, like the Slack workspace, if you will, and sort of keep track of who's following the law. We've done things like this before. In the US, the Nuclear Regulatory Commission places inspectors in every civilian nuclear power plant. And there's, 2 inspectors. There's on site every day. They make sure that everything's going well, that the rules are being followed. That's, a high stakes industry, nuclear power. And we've decided, maybe we should have some government oversight of what's going on here to make sure people are following the rules. And so I think, that's the sort of idea of auditors kind of similar to that. Maybe the auditors are going to be, one from the US and one from China, and they're going to come in and they're going to sort of check that everyone's following the rules and everything's going well. People aren't doing the research that they're not supposed to be doing. So that's one idea. An idea that I think is somewhat more promising is automating a lot of this monitoring process. So basically, one side effect of the creation of smarter AIs is that we have AIs that might be able to do our verification work for us. And specifically, we might be able to ask them questions like, hey, look through these 100 messages in Slack and check that if anyone was doing X thing that they're not supposed to do, and then tell us if so. And because they're AIs, you can sort of wipe their memory or the equivalent at the end. And there's many other mechanisms that you could use to make sure that you are using what we might call privacy preserving approaches to this monitoring.
I guess that's exciting and sort of terrifying at the same time. It could be applied to Slack messages, but also to emails, to cloud computing workloads, to basically anything someone does with a computer that isn't done completely locally.
Yeah, and I think, I mean, you could also imagine doing it locally if there was sort of a will to do that, right? Like there are scans like this, as in, I have a MacBook, and one thing that Apple does is when you run software, they often like run a check for, whether it's received the right signatures from Apple. And that's, I think they primarily are motivated by security there. They want to make sure that you're not like running malware or whatever. And so they do
Right.
some scan. But, that's like a very sort of silly version. That's not the kind of thing that we're talking about, but it just exists the case, or it is the case that there exists a bunch of automated monitoring that happens in the world on people's communication.
That's right.
Often this is fairly hidden. So one prime example is child sexual abuse material, or CSAM. A lot of common messaging apps do automatic CSAM detection, which they run sometimes in, what they refer to as secure enclaves, which is similar to what I've been talking about with this privacy preserving monitoring, where basically they, intercept your message. They run some scan of, does this message include child sexual abuse material? And if not, it's fine. And if yes, it's flagged, and maybe there's human review. So Gmail is a prime example of a service that many people use that is not end-to-end encrypted and instead has CSAM filters in the middle, where when you send an email, Google does a check. Are you sending this explicit imagery that's illegal and terrible? And if yes, there will be flags. And
Right. So we could apply similar technique to restricted research.
that's exactly right. And I think that I also, again, want to sort of caution that we don't need to apply this as a form of mass surveillance at all, because most people have nothing to do with frontier AI research. We're talking about a few thousand people that are actually relevant to the advancement of this technology that we might want to apply these sort of monitoring methods to. This isn't a sort of mass surveillance thing, because it doesn't need to be, because that wouldn't solve the problem. And because I think we should avoid bringing on risks like that if we can do so.
I mean, can I ask if there's an argument to be made for applying some of the techniques more broadly as a means of detecting covert projects that you would otherwise be unaware of?
I'm not sure. I think that if we could get the privacy preserving monitoring right, it might make sense to apply it more broadly. I think that we should be worried that we won't get it right. There will be, technical vulnerabilities that mean that it wasn't actually as privacy preserving as you thought. I think that, we sort of, saw this with the NSA, where, the NSA was like, okay, we're going to spy on Americans, but we're like only going to do it for legitimate reasons. Then it came out that some of the employees at the NSA were spying on people they knew, or, using the information accessible to them to look at people they knew. And so I think there are, real risks there.
Yeah.
And so I think we need to be super careful, but it's possible that we'd eventually want to extend this to a broader population. But I think it's not something you need to do immediately.
And to be fair, we have another researcher on our team who's looking at risks of authoritarianism that might derive from things like our agreement. And so this is something that we do care about, and we are researching and seeking to mitigate.
That's exactly right.
Let's continue. What role does evals play in research restriction verification?
Yeah. So I think there's a couple specific stories where evaluating AI models might be useful. So what I was just talking about, you have the Slack messages of OpenAI get, read by an AI that was sort of mutually agreed upon by the US and China to make sure that those Slack messages don't include restricted research. Well, we'd want to make sure that AI is actually doing a good job, right? You have a bunch of, one of the problems is sort of security. One of them is privacy. One of them is the competence of that AI classifier. So I think that's a place where evaluations might be useful. There are a couple other places as well. One sort of, I think this is a fairly goofy idea that I came up with, but what we were just talking about was a pretty hands-on verification regime, where again the inspectors, which are from the US and China, are looking at different AI projects or AI startups, for example, and saying, okay, you're not supposed to be doing restricted research, but we're like a bit worried that you might do it anyway. We're going to, install some extra monitoring to make sure that you're not, for example, having, AIs be reading your Slack, basically. That's a pretty sort of like hands-on, nitty-gritty verification regime. I think that you could imagine also that countries aren't willing to agree to that for some reason. And you might be like, well, what do they have available to them to do verification, even if we're not willing to be that hands-on? And one kind of goofy thing is to evaluate the AI models that are being, created in the world and see if they're getting smarter. Why? Because the purpose of the agreement was to stop AI capabilities from advancing, and you have compute controls and research restrictions. And so if people's AIs get significantly smarter, then something has gone wrong, right? Either they've used more compute than they were supposed to, or they used algorithms that they weren't supposed to, or your prediction was wrong in some way. And so that's an example of, you could be evaluating the AI models that are produced, and then that's a place where you can do sort of a flag for extra review.
Yeah.
It wouldn't necessarily mean for sure that someone is breaking the rules, but it would be an indication that you need to go investigate further.
Right. You wouldn't catch covert projects, for instance.
Yeah, that's what a major concern is. Exactly the sort of the NSA won't be releasing their AI models publicly, because they're trying to run the sort of covert project.
Right, but it still would be work that would be worth doing. To catch public facing progress.
That's exactly right.
Let's talk about so there is a question of how you define what exact research is restricted. And in that definition, we have sort of research that is restricted and then research that's adjacent to that. Talk about monitoring that kind of research.
Yeah. So one component of AI governance research is that there are many problems and you can't solve all of them at once. This paper in particular does not try to solve the problem which research needs to be restricted. It instead asks, assuming we had a solution there, assuming we had a definition for restricted research, how would we go about monitoring it? Nevertheless, it's useful to think about two types of controlled or restricted research, one of which should be monitored and the other of which would be actually prohibited. Mm-hmm. And I think that's like a useful breakdown because, sort of one of the elephants in the room that we haven't talked about yet is that it's hard to know what the downstream effects of research will be, right? Sometimes people come up with an idea that they don't realize is going to have, implications 2 years later in an adjacent subfield that they weren't even aware of. And so I think because it's hard to know what the downstream impacts of research are, you're definitely going to be wanting to monitor more research than you actually are sure needs to be prohibited. Okay, that's why it's useful to have this breakdown.
So for monitored research, there is you talk about pre-registration of research that would occur, and I guess some monitoring of the outputs to understand maybe a pre-publication review of research.
Yeah, exactly. And so I think some relevant precedents here. We have institutional review boards that say, okay, if you're going to study human subjects, we're worried about you potentially hurting those subjects or causing psychological damage to them or whatnot. And so your research needs to be reviewed by an institutional board to make sure that it's compliant with sort of ethical norms. Mm-hmm. That's a thing that we do in a field already. And I think that I'm kind of, in this paper, I suggest maybe we want to do that as well for AI. Basically, we want to have AI research that, plausibly could impact frontier AI capabilities should also be subject to a review process. Now, IRBs are slow. And so this is another opportunity where I think we can automate this process and make it much faster. We can have smart AIs review those, research plans basically. And one of the reasons to make this fast is that AI research is also generally much faster than psychology research. Psychology research, you need to recruit participants, you need to bring them in. Sometimes you have, week-long interventions or month-long interventions. AI research is generally much faster in the sort of feedback loops and the rate of experimentation that people are doing. So you definitely want a rapid iteration loop there in terms of making sure that people's research ideas get approved if they're acceptable. That is, if we think they're unlikely to improve frontier AI capabilities.
There's also a component of outreach to these researchers to make this process work.
Yeah, exactly. So I think, if you're going to impose rules and restrictions on an industry, it might really help you to tell them about it. And to sort of educate the folks involved about what the rules specifically are and what they, can and can't do. And in this case, what they can do, but need to sort of report or talk about, and then what they can't do. So I think, this is sort of an obvious thing that might help a lot, is sort of having education and outreach for AI researchers. This also might help with whistleblowers a bit. Whistleblowers might be unsure whether the activity that they're seeing or part of is actually a violation of the agreement. And so better education outreach could really help there.
Makes sense. The research also goes into, it's not just AI research, it's also research that could, for instance, do things like improve the efficiency of compute or make it more easy for more people in the world to manufacture AI relevant compute, for instance. There are some specific techniques for restricting that type of research as well that you talk about.
Yeah. So one of the ideas here that David's getting at is, okay, in our agreement, again, this the question of which research is restricted is sort of out of scope for the current paper, but it does matter. Very plausibly, an agreement like this would restrict research into better AI chips or, more efficient algorithms and stuff like that. If we're looking at restrictions on chips, fortunately, for the sake of verification, the compute supply chain, that is the supply chain for producing AI chips, is very concentrated and highly complex. There are, somewhere between 1 and 4 companies, depending on how you count, that can do the fabrication for these chips. That's TSMC in Taiwan, Samsung, Intel, maybe a couple others, but TSMC is doing the vast majority there. And there's not that many companies that can do chip design. Also, the chip designers are largely relying on a few tooling companies. So basically, we have this very narrow supply chain with a bunch of different, soft and hard choke points. Where the hard ones, maybe there's 1 or 2 companies. The soft one, there's 7 suppliers. 7 suppliers is nothing in terms of the government being able to actually impose any rules or monitoring here. The government could totally do it if we wanted to. And so basically the idea is, well, our chip supply chain is, has a bunch of these bottlenecks. So if we want to make sure that people are not producing new chips, there's a bunch of places that we could intervene to impose the monitoring that we need to make sure people aren't making better chips in violation of the agreement. Again, if that was part of the agreement.
Great. Let's talk about verification for the use of declared chips.
Yeah. So again, this is looking at the bucket of known chips. Sort of these are not a covert project. This is more chips or a data center that are known to the international authorities.
Part of the agreement is consolidating chips into compute clusters that are covered and monitored.
That's exactly right. So yeah, that's sort of upstream, and then we're like, okay, so now we have some chips. We know where they are. We want to know what they're doing, and specifically, we want to know what they're doing as related to restricted research. As a bit more background, our agreement goes into more detail on what sort of mechanisms one could use to do this compute use verification or chip use verification. In this paper, I focus on the elements of that are especially relevant to restricted research. I think there's sort of 2 broad directions. One is the automated researchers that I was talking about earlier, where again, currently humans are the ones conducting the vast majority of AI research. In the future, AIs themselves could be conducting that research, and so we might want to do monitoring of the chips for that kind of thing. What does that look like? It looks like monitoring the inference workloads the AI chips are using or are running that involve AIs. So the key precedent here is that currently AI companies do a bunch of monitoring of AI inference. For example, their monitoring is asking questions like, is this user trying to build a cyber weapon? Or is this user trying to build a biological weapon? Or is this child asking for child sexual abuse material? And if you do those things on most AI sort of chat platforms, you will get a message that pops up saying this is not allowed. This is this query is a violation of our content policy. They don't do that via magic. They often do it via these classifiers that operate above the model, sort of looking at what the user inputs and the model outputs are.
Is that work facilitate international verification? Would there be a problem here of saying, look, we're confident, I'm a provider of AI inference and I'm confident that nobody's using it to do research, but how can I prove that?
Yes. So there are remaining gaps between what is done today and what we need in an international agreement. There's basically 2 types of gaps here. Making that verification stack, making the monitoring stack or the classifier stack actually verifiable to the international inspectors,
right? And
then also making sure that you're monitoring for the right things. Yep. The second part's, basically trivial. You just need to, train your classifier to be able to detect restricted research, which again, if we had good definitions for restricted research, should be pretty straightforward. Also, it doesn't need to be perfect because you can do escalation, for example, escalate to human review or escalate to review by a smarter AI. Those are standard things that the field of, current inference monitoring already does. And then the first part is going to be the tough one. It's how do we make sure that, so again, OpenAI is running inference on their models, let's say. The rule is, okay, OpenAI, you're not allowed to do any restricted research in your inference. You then have the question, well, is all the inference getting monitored? That might be a sort of one place where there's leakage. For example, someone at OpenAI might try to set up a separate inference server that's not being monitored by the international authorities, or that doesn't have that inference applied, or that monitoring applied. And then also there's for the chips that you know about or whatever, is the actual correct classifier running and stuff like that. And those are technical problems, but there are ones that our team is working on and ones that folks outside our team are also working on. They might be very hard. I think these aren't going to be trivial problems, but I think they're also problems that if this was a high priority, I think we could certainly figure out. And there's multiple approaches that seem promising to actually pulling that off and getting that technical verification.
Another input to making frontier AI models is data, and data can be improved over time.
Yep. Yeah. I think this is a tough one. While writing this paper, I thought a lot about, okay, how could we make sure that people aren't using, better data than they're supposed to? And I don't think that I have a great answer. I think I have some answers. One of the maybe best answers is to sort of keep track of the data that's used to train AIs and then run some classifiers over that data to make sure that it doesn't have some property that you are worried about. For example, the agreement might say you are not allowed to use more than 10% synthetic data in all of the data that you use. So if you want to train on 10 trillion total tokens, only 1 trillion tokens can be synthetic data. Again, synthetic is AI generated data. The rest have to be, human books or Wikipedia or whatever else. That's like one operationalization. It's sort of silly. I think it would be hard to get the operationalization right, but it's probably possible. And then, okay, how do we verify that? Well, you have find a way to get the company to sort of report that data, verify that it was actually the data used to train the model. There's some ideas on how to do that. There's a paper about this topic. And then, basically you just check, does the data have that property? For example, for the specific implementation I just suggested, or the specific rule that I just suggested, we would check, we'd run an AI text detection basically over the data. Now, current AI text detection is imperfect, so you need to improve on that for this to be highly reliable. But that's sort of an overall approach that you might use. I want to note also that there's relevant precedent here, not from the verification side, but from the company side. Companies filter their data in various ways because they don't want to train on bad stuff. For their use case, bad stuff includes, child sexual abuse material or personally identifiable information. So when they're taking in their, giant swaths of internet data and deciding which to train on, they run plenty of these filters and classifiers already to look for, is this training data have X property? Where again, X might be, a dangerous description of how to make a bomb or something like that.
And so you could detect synthetic data or otherwise curated data this way.
In principle, yes, or using similar methods, basically. The idea on gesture as the industry is already doing a similar thing and is building the sort of methods and tools to be able to do this at scale cheaply. You'd just be able to apply it, here for the classifier that you've come up with.
I think we should move on to talk about non-proliferation. This is as it relates to the proliferation of I guess further inputs to developing frontier models.
Yeah. So again, I think that I went through this arc when writing this paper of starting off going, oh man, it's human researchers. There's a few thousand of them. These are very, rare talents, if you will. These researchers get paid, often millions of dollars a year, if you include equity, to work on this frontier AI research. And the reason they're paid that is because there aren't that many people who are actually capable of doing this work.
That's right.
And I think that throughout the project, partially because AI has continued to advance since I started the project.
In the months.
in the few months that the project took, I'm more and more worried that soon we'll have AIs that are capable of actually doing the AI R&D process. So I think on the non-proliferation side, ideally, we would prevent those AIs from being developed in the first place, and then if we fail there, prevent them from being proliferated widely. Let's walk through those in more detail. So, the problem, AIs will eventually be able to do AI R&D, and so therefore, if you wanted to restrict AI R&D, you need to, it gets much more difficult to do that, because instead of it being a few thousand people, there is, an AI that maybe it requires 10 GPUs to run, or maybe it doesn't, right? I think we have this trend in which I believe work from Epoch indicates that it's maybe something like 8 months that it takes for frontier AI capabilities to be available at the size that someone can run on consumer computers.
Wow.
And so I think and I wouldn't be too confident in the numbers there or anything, but I think there's certainly this trend where smaller AIs get better and better. Smaller AIs can be run on a personal computer. And so if those AIs were widely available, for instance, someone released the weights of such a model on Hugging Face, then we would have this problem of, well, how do we make sure no one does AI R&D with that model? And it's basically impossible to do that, I think. So we'd like to prevent that from happening.
Yeah,
two ways
not
to-
without taking away my graphics card.
Exactly, and I really don't want to do that.
Right, that's right.
Yeah, so I think the two approaches there is prevent the development of those AIs in the first place, and then prevent the proliferation of them.
Yeah.
On the proliferation side, that might look like having commonly agreed upon norms between the U.S. and China for which models we're going to release open weight versus which models we're going to keep proprietary. That's like one mechanism you might do. You also would want to really beef up security at frontier AI development companies. So currently, the AI developers are not on track to be secure against advanced state actors anytime soon. And so what will actually happen is what I expect to happen is that some AI company in the US develops a model that is capable of accelerating AI R&D substantially. And then within a couple months, that model gets stolen by a foreign adversary government. And then that foreign adversary government now has that model. And so if you wanted to try to stop people from doing restricted research, you now care about not just does OpenAI have a model that can do that, but some number of other actors, including whoever stole it and whoever they sold it to, et cetera, have access to that model as well. That's really tough. I think that we're probably just going to have to accept that that's likely to happen and instead ask the question, okay, how can the relevant, cyber capable state actors hold themselves back from releasing these models, which I think is very reasonable. So what I mean by that is, for example, the MSS in China steals the model from OpenAI, and then instead of open source releasing that model themselves, and instead of selling it to everyone else in the black market, they should also try to lock it down pretty hard and they have a lot of security around that model and try not to proliferate it further. And then it might be possible to have an agreement in which, China goes, okay, we see that OpenAI had this model. We also happen to have that model. Sorry, guys. But we haven't proliferated it any further. And so we are quite confident that if we lock down this model successfully, no one else would have access to it. And then, the question is, can the MSS and OpenAI secure that model sufficiently, which I think is very, is plausible, except for the problem that it got stolen from OpenAI in the first place. But there's some, the number of threat actors that could steal a model from OpenAI and the MSS is relatively small.
Even today.
And so I think that's sort of the story that I would hope for there is, state actors are probably going to get their hands on some of these models that are trained by companies. But if they, play their cards right, if they take security seriously, we can still keep proliferation relatively small.
Is it also
kept to a small number of actors?
Do you also just cover the idea of improving security at the labs themselves to prevent theft?
Exactly, right. So I think that, on the default trajectory, the thing that will happen is the models get stolen and proliferated. Now, they might not get proliferated widely. Again, that's where I think the MSS needs to improve their security.
Big difference.
But I think there's an opportunity for also OpenAI to beef their security. Unfortunately, I think that's going to be really hard. So it's not an easy ask, but I think that would be on the wish list for sure.
Well, hopefully we can prevent the development of the AR and capable AIs in the first place, so we don't have this problem. But
Agreed.
It's good to have a layered defense. Talk about non-proliferation of AI algorithms and data. This seems difficult to prevent certain types of knowledge from spreading.
Yeah. So again, the focus of this paper is verifying restrictions on frontier AI research, and notably, AI algorithms often either build on each other or are complementary to one another. For example, using the correct version of layer norm stacks with using mixture of experts versus a dense architecture, right? Having multiple of these algorithmic innovations helps you out over just having one of them. And so the overall goal of verifying these research restrictions, one of those goals is to slow down covert projects, basically. And again, we're going to try to slow them by making it so that they are not allowed to do frontier AI research. But another way to slow them that's related to AI research is to try to limit what they get their hands on immediately. And so I think you can do that by trying to, again, have norms around open source. What ideas do you want to sort of publish widely and broadly versus keep close to the chest? And I think also this goes for data as well. So I think, currently AI companies are scaling up the RL environments that they're using to do post-training. And that's kind of that's a thing that they're doing. Now, there's a question of how much they want to proliferate those environments or sort of spread them widely. And I think that, it's not obvious, but I think there's a concern here where if you released a lot of those publicly and made them widely available, then there's a risk that bad actors would get their hands on them in the future, and it would speed those bad actors along. I want to introduce a major caveat on these points, which I think it's really hard to know when the relevant time is to do some of this closing down. I think that open source has historically been quite good for the field of AI and AI safety, and I think in general open source is very good for the world. Unfortunately, this AI technology is different from a lot of other technologies, and because of the risks, I think we need to approach open source quite differently from how we approach it with other technologies. But I also wouldn't be totally confident that I or anyone else knows exactly where the lines should be. And so I think the point of the paper is not to I'm not confidently saying we need to ban the release of new AI algorithms, but I do think this is a thing that should be considered when people are thinking about how could we actually reduce the risk of covert projects under an agreement continuing. And one of the things you could do is reduce their access to information about how to do frontier AI development, making it harder for them.
Maybe a question I'll end on is to the degree to which we should be worried about proliferation of these inputs prior to the implementation of an agreement. And I think you can look at this through two lenses. One is just it may take a long time before we get to an agreement. How much worse do we think the state of the world might be by then? Two, if certain actors see an agreement coming proximately, should we be worried that they will take actions that will sort of undermine the agreement before it can be put into place?
Let me start with the second one. Yeah, I think we should probably be worried that actors will try to undermine the agreement. We shouldn't necessarily be worried because I am very confident that they would do this, but I think we should feel worried because, again, we want to have minimal trust assumptions if we can, right? The US and China don't trust each other. And, if there was a hinting of an agreement and then 6 months later the agreement came into effect, both sides would be extremely worried that in those 6 months, the other side did something to make this agreement harder to verify. So I think that is a very serious concern. I think there are some things that folks, that states could do on the algorithm side to try to make this harder to verify. But maybe I won't give them ideas there. And then,
well, actually, but I want to mention on the positive side, there's also things that states can do ahead of an agreement that would make verification easier and would actually serve to build confidence towards an agreement being possible in the first place.
Yeah, that's exactly right. And I think that our team has thought some amount about that question. And we think that basically there's a lot of stuff on the compute side that could help here. So sort of consolidating compute early and sort of starting to monitor AI chips early could be a big win there in terms of making it less likely that someone, one of the concerns is that someone has a secret data center that they're using to run their automated AI researchers and run a bunch of experiments. And so if you can keep track of the chips and where they are earlier, then you can make it much more likely that you don't have those problems.
Did you want to say anything about proliferation that may occur just in the time it takes to go from here to there?
I'm not sure.
Okay.
Do you have takes?
Well, I think my major takeaway is that this is the fact that this proliferation is presently happening, is going to continue, is a reason why we need to act sooner rather than later. That the situation largely gets worse, not better.
Yeah, I think that's right. I think that, again, one of my big takeaways in this research is we should really be worried about automated AI research. And that is a problem that, again, no one knows for sure when we'll have those AIs, but they're going to cause major problem. It would be great if we implemented an agreement like this before we had those AIs.
And the labs are telling us they're coming quite soon, anything between 1 to 3 years.
Yep, that's exactly right. And I think that independent experts, including myself, basically agree with those timelines. It looks like this could happen really fast and really soon. And the world's not ready.
Anything else you want to say about this research, Aaron?
Let's see. I think maybe I want to sort of try to convey the whole story as I see it, excluding the specifics of the mechanisms, which we spent a lot of time on.
Okay.
The entirety of the story as I see it is as follows. We and many experts around the world are worried that advanced AI will cause catastrophe, including human extinction, if it's developed soon. We think that one of the best approaches to deal with that problem is to not build it. If you're worried about the superintelligent AI killing everyone, don't build the superintelligent AI. We wrote an international agreement where we sort of tried to answer the question, if there was a lot of political will to not build it, what do we want the world to do? And we suggested this international agreement with compute controls and research restrictions. This paper is looking at how we would verify compliance with those research restrictions. It's not looking at exactly how to define them. Again, our best guess right now is that you should focus on research that's likely to improve frontier AI capabilities, to make AIs more compute efficient, that's likely to endanger the verification regime in other ways. For example, distributed training might endanger the verification regime. Making, chips that are better in certain ways might also endanger the verification regime. But that's out of scope for this paper. This paper instead looks at the question of how we would verify compliance with these restrictions. Again, we can break that down into sort of whether humans are doing AI research and whether AIs are doing the AI research. And we can also break it down into covert projects versus known declared projects, where you need to go, you need to go find the covert projects, but you need to make sure that the declared projects aren't doing anything that they're not supposed to, even if you already know, who is involved and where their facilities are and stuff like that. And again, this paper sort of takes a first pass at answering what could we do to make sure everyone's following the rules there, both on the finding covert projects and the monitoring known and declared projects and monitoring known and declared chips, and then also non-proliferation. I think there's some concerns and like risk with this research and with the overall idea of doing research restrictions, which are pretty important to talk about. I think mass surveillance is pretty terrible, and I hope that we don't have mass surveillance in the future. I'm also optimistic that we won't need mass surveillance in order to deal with this problem. Part of the point of this research is to try to figure out what are the promising pathways, taking into account those costs and risks. And so I think that's, this is a really important problem. Future work on this topic should definitely keep those risks in mind. I think, to sort of like state it more clearly, I think the risks include, political oppression, suppression of legitimate research, just like surveillance overreach, and also security leakage. These are sort of four potential problems here. And I think that, we need to be really careful about this. This is not an easy pathway to navigate, but I think it's also not, I think it is both possible, and I think also often people don't consider the alternatives, where, let's monitor research to make sure that people aren't doing dangerous types of research might sound a bit scary, but I think it also sounds pretty scary to imagine frontier AI development continuing as it is, and the sort of wealth concentration that will result from that, and the mass surveillance capabilities that state actors will have. And so I think that, we're on a trajectory that includes a lot of authoritarian risk. If we were to get off that trajectory and move to an international agreement, there's definitely some authoritarian risk there too. I'm not sure it's higher or lower. My guess is that it's lower than the current path, but I think we certainly want to be aware of that risk and try to mitigate it in the implementation details of things like verification for research restrictions.
So in short, with the conscientious and well-intentioned, diligent efforts of enough people, we may be able to figure out a way through this.
Yeah.
Aaron Scher, thank you so much. Again, my name is David Abecassis. We both work at the Machine Intelligence Research Institute on the technical governance team. Thanks so much for listening.
Thanks, David.